This is part 3 of version control, and we're going to look at some slides and kind of dive into version control even a little bit more deeply. What is version control? Well, in our context, we're really talking about keeping track of changes to files containing code, but it can really be used for other things. For example, managing documents. And well, for me at least, it's pretty easy to picture what would happen if we didn't have version control. Things would kind of dissolve into chaos. If you think about the Linux kernel, so that was developed by not developers sitting in a room together, but it was developed around the world. So you have many people working on code at the same time, split between all these files. And that's like a really hard problem to keep all that work coordinated. Here are some kind of the keywords that you use when you're talking about version control. There's a repository. That's the name you use for the spot where you're keeping all the files. And that repository could be on some remote system or it could be on your local system. So for example, at the college where we have custom code written, the repository is local to the server where we wrote the code. It's not in the cloud or anything. There's two types of version control, centralized and distributed. And we're going to be talking about both of these in more detail. But with centralized, you have a server and it's holding one instance of the code base. And with distributed, there are multiple instances of the code base. Basically meaning for all the different people that are working on the code, they have a copy of the code, but it's coordinated. Centralized came first. It's kind of a little bit easier to understand. You can almost think of it as the library model where you kind of have to check out a book to work on it and you check it back in and there's just one copy of that book. But distributed has a lot of powers that make it in ways a better approach to use, but it gets more complicated. So with centralized, for example, you have one copy of the code. Well, that's a little bit dangerous because if that centralized thing failed, you don't have any code left. That would be just like you have all the books in one library. If the library burns down, you don't have the books anymore. Whereas the distributed model, you have copies of that code. Here's the picture of centralized version control. In centralized version control, we have a server, and it has a version of a file it's keeping track of through some mechanism like a database. And then computer A checks, somebody at computer A checks out a file and somebody at B checks out a file. It's all coming from the central server. This you can contrast it with distributed. So in distributed, each client holds a complete copy of the code base. And you share the code between the clients by pushing and pulls back up to the repository. So the advantage is that many things are cheaper because the person has a complete copy of the code on their laptop, for example, so they can kind of work independently from that repository. If that central repository fails, it's not catastrophic because many people have copies of the entire code base. The disadvantage is it is more complicated. Just to compare these two, so the centralized one, we have one repository. To work on the code base, you have to be able to connect to that repository. And you have to solve the issue where two people change the same file at the same time, right? There's kind of both person A and person B change the file and they want to check it in. You do have that issue of resolving how are you going to put those pieces together. The distributed, everyone has a working copy of the code. It's faster because right on your laptop you have all the code. You're not going up to that central repository to get stuff because you have it all. You could work even if your connection was down, if you weren't connected to the network. You'd still be able to do it. You do have this issue about two people changing the file at the same time. So that also has to be resolved, but that's not a reason not to go with distributed. Okay, question for you. In IntelliJ for the College World project, which do we have? Are we doing centralized or are we doing distributed? Which do you think it is? Do we have a copy of all the code on our laptop, or are we just getting one file and all the code is coming from the repository? And the answer is we are using distributed because we have a copy of all the code. And we can actually see all the code on our laptop. I'll show it to you in a second. So if I go to any spot here and I click on something, the code instantly comes up. It's not like we're going to a centralized repository asking for a copy of it and it's coming down. We have it all locally on our machine. And if you navigate to the right spot on your laptop, you'll actually see the code. It's all sitting there. Git. So Git came out of the Linux development environment. They had the goal of developing Linux by using people distributed in different countries, and the goals of controlling the code were it had to be some sort of fast way of controlling the versions of the code and be able to support people kind of going off on tangents to develop kind of like a little bit of a parallel branch for a feature they're developing and then folding that back in. We're going to talk about that a little bit more, branching the code. Is Git distributed? Well, we've sort of answered this already. Git is distributed. We have a local copy of the code. We're using Git on this project. This is a picture that's kind of comparing the two models, centralized and distributed. This picture is a little bit confusing, but really it's showing that you have a server computer. This would be GitHub up in the cloud. But locally on my laptop, I have a version of all the files, and so do you on your laptop. This is a confusing part about Git when you go to work on it, is that you have all the files sitting there on your laptop, and at least initially they're all unchanged, and then you touch a file and it turns blue because you've modified it. And then at some point you can say, well, I'm going to commit this file, and you do a step and you do the commit, and then there's another step that you take which actually pushes it up to the cloud. So there's kind of a two-step in getting that file up there, and that can be confusing. With Git, it uses checksum as a way of producing a unique identifier for each set of commits that you are making. And we can see that if we go into GitHub, you'll see this little identifier code of the set of changes that you've made. Here is a set of changes that I submitted earlier where I happen to have just changed one file, but I actually changed a whole bit. If you look down below here, you can actually see the giant identifier for that unique ID for that set of changes. Okay, we're going to break here. The next video up, we're going to go into more detail about chaining all these submissions together and how that all works. It's a little bit more complicated, so let's kind of take a break and we'll pick it up in the next video.